All right, so for question 17.1, the ratio of the conjugate acid and conjugate base in blood at pH of 7.4. So you might not know where to start this question, but basically when they're asking for the ratio of the conjugate base to the acid, you should think about, well, we know equilibrium constant Ka is the product of proton concentration times conjugate base divided by the concentration of your parent acid. And we're looking for that ratio. So if we separate out, well, first we can plug in the two ions that we know, and then we can rearrange that to separate out basically what we want to find out, the ratio of Ka to proton concentration. And you see that leaves us with our ratio of the conjugate base to its acid. And then all we need to do from there is we can switch it around to solve for basically that ratio. Look up Ka from Appendix D in the back of the book. Ka for carbonic acid is 4.3 times 10 to the minus 7. And we remember that pH equals negative log of proton concentration. So if we want to find the proton concentration, we just take 10 raised to the power of negative pH. So now we have our Ka, and we can plug in for H+, divide those two, and we should get our ratio of the two species in solution at pH 7.4. So I've just plugged in Ka here up top, divided by the basically 10 raised to the negative pH. So we get 4.3 times 10 to the minus 7th divided by 3.98 times 10 to the minus 8. Divide those two, and we should get a ratio of about 10.8, and because it asks for two significant figures, we'll round that to approximately 11. Now, for the second case, part B, when the blood pH drops from 7.4 to 7.2, it's basically the same calculation as above, with the exception that now, we're going to get our proton concentration, our H+ concentration, from a pH of 7.2. So we take the same equation, plug in the same Ka because it's the same acid in question, and now we just divide that by the new proton concentration, so 10 raised to the negative 7.2. That gives us 4.3 times 10 to the minus 7th divided by 6.3 times 10 to the minus 8. We divide those two through, and we should get about 6.8 for a ratio, and again, we'll just report it to the nearest whole number, and we'll call it 7. So that's how you basically solve this problem. Just think about what the Ka stands for, and then how can we separate that out to just get the ratio between the conjugate base and its parent acid at different pHs.